Okay. All right. All right. Okay, so we want to get the domain and the range. I know this one looks a little bit different than what we saw before just now, but it's really the same idea. Okay? Really the same idea. Again, if you can't see the slides or something, just let me know. But it's really the same idea though. So let's go through with, let's get the domain. So again, we're at the graph, right? Here's part of it. We have to go up or down to the x-axis, right? Like so. And that's what I'm doing, okay? As you can see, I'm going up or down to the graph, right? I mean, in this case, I was going up, although the graph now is above the x-axis, so maybe that's better to say. As you can see. Like so. Okay, going up. You know, I know these lines are supposed to be vertical, so bear with me as I try to draw them. Doing whatever I can do. Okay. Okay. But hopefully you can see from here that the interval from 0.5 all the way to 6.5 is going to be the domain. Again, because that's the part of the x-axis that's either above, as over here, or below the x-axis, as over here. Okay. All right. Now, what about the range, though? Well, the range is the same idea, but let me erase it, though, so it comes out nice. Good. For the range, right, what you want to do is draw horizontal lines to the y-axis. Okay. So that's what I'm going to just do here. That's -1, as you can see. Right, so where I'm drawing from -1 up to whatever this is, that's in the range, as we can see. Like so. Now notice, oh wait, we're not there yet. Although you might. So we keep drawing the range. Okay. Now notice also that I didn't draw the horizontal lines past this to the other part of the graph. I mean, now I did, but before I didn't. I don't have to, because all we care about is the range. All we care about is the portion of the y-axis to the left or right of the graph. And here, it's enough to draw over here. So, as you can see, we keep on doing this. Keep on going. So, hopefully you can see that everything from -1 all the way up to 2.5, all the way from -1 up to 2.5 would be the range of this thing. Again, I didn't go past this part of the graph, past here. I didn't have to do that, because all we care about is the range. All we care about is the part of the y-axis on the left side of the graph. By hitting this part of the graph over here, hitting the graph once, that's all we need. I mean, there might be two different inputs that have the same output, but for now, we don't care about that. So that's what the range is. Any questions? Okay. Well, that's it for this chapter. So now what I'm going to do is I'm going to start the next chapter, chapter 3. So let me get those notes up. All right. Where is it? Oh. Let me open that up. There it is. All right, here we go. Okay, so here, what we're going to see first in chapter 3 is we're going to see how to graph quadratic functions. Remember, what is a quadratic function? Well, that's a function of this form. F is the function, okay? But you can really call it f, g, whatever. It's a function that's defined this way, where ax squared plus bx plus c is, excuse me, f of x is equal to ax squared plus bx plus c. So the function is defined by a polynomial of degree 2. You know, quadratic, in other words. It's a quadratic of degree 2. You know, as before, a, b, and c, these are all real numbers with a not equal to 0. I mean, if a was equal to 0, we'd be back in graphing lines, and we did that already. So that's what a quadratic function is. The graph is called the parabola. And as we saw before, it's going to be some variation of the graph of y equals x squared. Okay? It's going to be some variation of it. Variation meaning it might be shifted horizontally or vertically. It might be turned upside down, that kind of thing. What's nice about these functions, as on the slide, is they all have the same domain. They all have domain, all real numbers. You know, this interval is all real numbers. The range, that's a different story. Excuse me, the range is actually going to depend on A, B, and C. More on A and B than C, but it will affect the range. All right. These are just some examples to help remind us what the graphs could look like. You could have something like this. Also note that we didn't have arrows here. I didn't draw. But the graph does keep on going up, up forever. Or it keeps, as in here, it goes down, down forever. Okay? That's what's happening here. Okay. So here, for instance, we have the graph of y equals x squared plus 1. Okay. And you can see here, hopefully you can see that the graph looks like y equals x squared. You basically shifted it vertically up 1 unit. Vertically shifted it. Whereas here, it's pointing downward. Okay? That's what happens here. Again, I'm just really reminding you what the graph could look like. But you can see it's some variation of y equals x squared. I mean, here I'm taking y equals x squared and moving it up 1 unit. Here I'm moving it, I'm turning it upside down and moving it up 1 unit. Okay. All right, that's good. And now there's also another reason why I put these graphs here. The a, remember, that's the coefficient of x squared. Okay? A is the coefficient of x squared. Remember, if it's not there, it's understood to be 1. So here a is equal to 1, and the graph is pointing upward. Okay? Here, the a is negative 1, okay? And the graph is pointing downward. Well, that's no accident. That's no coincidence. Namely, in general, if your a is positive, the graph's going to open upward. So in other words, if a is positive, the graph's going to do something like this. See if I can draw it. So this is when a is greater than 0. Again, I put the arrows here just to indicate that the graph goes up forever. Whereas if a is negative, it's going to do something like this. Do, 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 do. Like so. So this is if a is negative. Like so. Okay? As you can see. As you can see. Okay? So that's what happens here. So this is how this is one way a affects the graph, so to say. And I did try to draw it here, but it's better seen here. There is, here, let me get to the laser thing. There we go. Notice there is a point, so to say, where the graph changes direction. You know, in other words, if you were to imagine walking along the graph, you know, right? Here you reach, in this case, the lowest point, but now you're changing direction. You're walking the other way now, making a U-turn, so to say. Over here, same idea. You're walking along the graph. What happens? You hit the top, and now you turn around, and you come the other way. You turn and walk the other way, excuse me. Walk in the other direction, that's better. Well, this maximum point and this point over here, where the graphs change direction, those points are called the vertex of the parabola. That's what the vertex is called.